Hello, everyone, and welcome to the EclipseStore Fundamentals training. I will give you a short introduction of the training within the next 5 minutes, and then I hand over to Marcus for the theoretical part of EclipseStore. But the important things first, this training will be recorded, and you will get access afterwards. So that shouldn't be a problem. God, what's wrong with my presentation? Okay, a short introduction about me. So my name is Kuemmel. I'm Java developer for, let's say, 15 years now around. Currently, I'm project manager of the microstream cluster development, and I'm also involved in some projects of the Allianz insurance company, Fraport. And yeah, maybe we saw each other on the JCon 24. And that's why I'm trainer and conference speaker. Yes, and yeah, I'm the trainer for today together with Marcus. We started at 5 and the training will go to 9, and there are 5 lessons, I would say. And the fifth one is a Q&A session, let's say. It depends on your questions. And that brings me to the most important information. So we already talked about that. The material, you will get access to the recordings after, and you will also get access to all the projects and code and demos we do in that project. I always will link you the GitHub repositories where you can find all these examples we do during the training. Questions, that's important. If you have any questions, feel free to ask within the chat. I guess we are 23 people for now. It makes sense to write down the questions to the chat. Maybe at the end, during the Q&A, you will be able to ask via microphone. It depends on you. Let me directly share you some links. So there are some EclipseStore GitHub link. This is where you can find EclipseStore itself, some examples, and so on. And the documentation is also there, and the training examples. Give me just a second. So let me just share with you the links directly. Here we are. Okay, so now you should see all the links in the chat. So just copy paste it. The most important ones for the training are the examples. It's my GitHub repository. Here we'll find all the examples. And there was also a question regarding certificate. You will get one after the training. Just visit our cloud front end, and there is one part you could click on certificates, and then you will see yours. But the important thing is you have to register there, and you have to use the same email address you used for the training now, and then you will get your certificate. Okay. Let's talk about the topics. So as I already mentioned, we start with an introduction to EclipseStore with Marcus, around 45 to 60 minutes. It depends on Marcus, I would say. Then I step in with a quick demonstration, and then we do some step-by-step configuration of EclipseStore. This is a hands-on demonstration, so you could code along with me if you want. I always integrated some branches for you, so then you can code along with me. We create a CRUD. We're talking about CRUD operations. We're talking about creating proper data models, and what's the most important things within data models when you use EclipseStore. We have to talk about queries, or better say Java Streams API. Some of you might not use them that much, and it's always great to see how they work. And we have to talk about lazy loading and why should we use this and why is that important. And at the end, we have a short look to the client UI. So it's kind of like an administration view to the data. that helps you at the beginning to see what happens with the data and to see what's going on the database side. Okay, so that's all from my side so far. Now I will hand over to Marcus. Marcus, it's your turn. You should be able to share your screen now.
Okay, thank you, Christian, and welcome everybody to our fundamentals training for today. So today we are very international. Is someone from Switzerland, by the way? You can use your chat and you can also use your microphone, of course. So if someone is from Switzerland, please no bad comments about ice hockey. So Switzerland is leading against Germany right now. So okay, please ask as many questions as you like. You can interrupt me anytime, and especially when we do the coding section with Christian. I like to introduce you to the functional principle of EclipseStore, because the functional principle, to know more about the functional principle is very important. And I like to talk about the differences between traditional databases and EclipseStore to be able to introduce you to the functional principle of EclipseStore. So here are some further information about training courses. We provide further online training courses, and we have a small gift for you. So all participants to today's workshop and all participants at JCon will get a code for the advanced trainings as well, so that you can join the upcoming EclipseStore advanced trainings for free of charge. And we have also EclipseStore starter days. So it's because of the last 2 years we only had these online trainings and online introductions. And from now on, we will also provide again on-site trainings, on-site starter days, where you can also meet the team and where we go more into practice and get started coding. So you can enroll for this training for free. We are in Düsseldorf, Ratingen, London, in Prague, and in Munich. So if you're interested in, you can enroll for free at microservices.one starter days. So take the chance. We're looking forward to meet you there. So EclipseStore in a nutshell is a Java persistence layer that is built to create high performance data processing applications. It runs embedded within your Java application or your microservice written in Java, and provides you persistence for all of your POJOs. So we have no requirements to your classes. You can build whatever you like. And EclipseStore will be able to store it persistently on disk. It enables you to store any Java object graph, any kind of Java objects, any size and any complexity of the object graph, transaction safe into any data storage, into any binary data storage. So you can choose your storage target freely, provides you transaction safety, and mostly you will store individual subgraphs. So you can store the whole object graph in memory, but mostly this makes no sense. Mostly you will store your object graph partially, so the changes are regular stored to disk. Vice versa, the framework allows you to load your object graph in memory and restore it in memory. And here is the same. So mostly you will load subgraphs and restore subgraphs in a memory when it's needed. So you can load again the whole database into memory. If you have enough in memory, then you can do that. But this is super important to mention. This is not mandatory. So you don't have to load the whole database in your memory. Mostly you will load only object references, only subgraphs will be loaded and restored in memory on demand. So, and there are actually 3 benefits coming with the EclipseStore. First is high performance. So you will be able to build ultra fast in-memory database applications. It's because of the performance of Java. You can save, so we say more than 90% database costs in the cloud because EclipseStore only requires a binary data storage and you don't need a database system anymore. In the cloud, object storages, binary data storages are around 95 or even more % cheaper than any database in the cloud. So we only need storage, and so this is way cheaper than a database. And third is simplicity. EclipseStore is a pure Java approach, and it's very simple to use EclipseStore. It's because of there are no database specific functions or concepts you have to learn. There are only Java concepts, and you should be familiar with all these concepts already. If not, it's not a problem. You just have to learn Java concepts. So it's open source. It's an Eclipse project since last year, and you can download it via Maven. And the open source license is the EPL, the Eclipse Public License. This is a great license. You can use EclipseStore for commercial purposes. Also, you can build closed source application and use it for your code. The code is on GitHub. With MicroStream, we are the company behind the EclipseStore open source project. We also provide you with a new indexing API and the cluster solution for creating distributed applications. So to explain EclipseStore better, it is easier to understand or to compare it with traditional databases. Here we have an overview of the architecture of a traditional database application. We have an application or a microservice written in Java. We have objects in memory or object graph, and we have the JVM. It runs on a virtual server in the cloud or a physical server, so it doesn't matter. And we have a relational database, and we have further challenges with the relational databases and Java as an object-oriented programming language. So the problem is we cannot store Java objects as they are in a relational database. So we have several impedance mismatches, and so we have to solve this problem, or there are frameworks that solve these problems for us. But I think the big challenge is with relational databases in Java, you have to build your object model and you have to adapt your object model to the relational model. So this is very important. And by the way, this is with all databases, it's the same with all databases. The databases come up with their individual data structure, data types, and we have to adapt our object model, our Java types to the database specific structures and types. Impedance mismatches. This is a well-known topic. You can read more about the internet and the challenges about these impedance mismatches. With NoSQL databases, this is very interesting because there are further new databases and they provide a different data structure and data types. So completely different in comparison to the relational model. And so here we leave the path of relational databases. We have several different concepts like column stores, document, mostly JSON-based databases, key value stores, graph databases. Object-oriented databases are very interesting. Developed in the 1990s time series, and now the vector databases. Here the same. All these databases, they provide their individual database specific data structure or types. An object-oriented database, this concept, I think this was obvious because we want to store our objects. So let's create a object-oriented database. But the object-oriented databases, they introduce their own database-specific object model. So we have the same challenges here as well. So we have to adapt our Java object model and map it to the object-oriented database models. This might be the reason why they are not so popular these days, because there are further challenges with object-oriented databases. And EclipseStore is not an object-oriented database, and it's not a graph database. Graph databases introduce their database-specific graph structure. No database on the market supports the Java object model, and this is the difference. EclipseStore supports the native Java object model, and we do not invent a new data structure. We use the native Java object model. So with relational databases, these differences between the language and the database is solved by object relational mapping frameworks like Hibernate. The standard here is JPA, the Jakarta Persistence API. So behind the scenes, through every single read and write, objects are generated, or SQL code is generated by the framework. So the framework in between has a lot to do. So there's a lot of overhead happening behind the scenes. And this is the reason why we have here latencies, so very expensive latencies. And we can accelerate these applications by using local cache. So this is also common to use a local cache. When we are dealing with distributed applications, then mostly the local cache is not sufficient, because if there are changes on one of your nodes, of your application nodes, application instances, then this node will be in sync with the database, but all the other nodes will not be in sync with the database. So you have a problem here with data consistency. And this is the reason why mostly in practice, a different cache strategy is used. So mostly, or very often, distributed caches are used in between. And so you can see architecture of our Java Enterprise application gets more and more complex. I'll talk about this. It's because we will compare this this architecture, this common or standard architecture with the EclipseStore architecture a little bit later. Distributed caches are not used by everyone, not everywhere, but a lot of organizations use distributed caches. Of course, we need a lot of memory. When we have more load on the database itself, then very often we see database clusters. So databases that provide replication to share the load. And so it's common to use database clusters without a distributed cache, or it's also common to use a distributed cache in between. So it depends on the use case, of course. With microservices, it becomes even more complex because each microservice should be scalable horizontally. So each microservice is actually a small cluster. All services have to be able to scale horizontally. And if you have huge applications, probably there are multiple databases in use for different use cases. For instance, you use a graph database for very complex data structure, and a document store for unstructured data, and probably use a relational database for as a main database. And vector databases are very popular these days because of AI and machine learning. So the architectural landscape is very complex. A lot of machines are used, a lot of memory is in use. It depends. So where the memory is, so mostly memory is hidden in deeper layers, in caching layers, or in the database layers. So mostly we want to avoid using big memory machines in our application. So, but we have a look a little bit deeper in the cache layer. Of course, we will find a lot of memory, or in the storage layer. Then we have the database servers, and mostly we have also a lot of memory to be faster. So this is the common architecture. And now the question is, how does EclipseStore work? But before we talk about EclipseStore functional principle, we want to talk about the cost. Here is an example with the PostgreSQL and AWS, or PostgreSQL at AWS. For instance, 250 gigabyte costs around $8,000. This depends on the size of your machine, of course. And there are different configurations. Probably you can also find a very cheaper configuration, probably around $4,000 per year. Doesn't matter. When we compare this with cloud binary data storages like AWS S3, this is super interesting because 250 gigabyte costs only $73 annually. So doesn't matter if you pay $8,000 or $4,000 for your relational database in comparison to S3 blob storage. It's very expensive, and the more nodes you need, the more nodes you run for replication to share the load on the database, the more you have to pay, of course. And with the binary data storage, it's only $73 annually. And so this is the reason why we talk about more than 96% database cost savings in the cloud. So you can check this out with your cloud calculator. It's the same with Azure Cloud or Oracle Cloud, IBM Cloud, Google Cloud. They all provide these object storages or blob storages. It's pretty much the same. So now with EclipseStore, we like to combine the power of Java with these low data storage costs in the cloud. The performance comes from the JVM. The performance does not come from EclipseStore. It comes really from the JVM because we have a JIT compiler. JIT compiler accelerates Java programs extremely, and we are reaching a microsecond response time by the JVM. So microsecond data processing and microsecond response time. This is reachable with pure Java. And we don't have to think about data structure. So with Java, we have objects, we have perfect data model, the perfect data structure, and it is a multi-model data structure from the beginning, because we can store simple values, we can deal with lists, collections, we can deal with graphs, documents, everything is possible. And also we can deal with vectors by using vector APIs. So in Java, this is not an issue. So we have already the perfect data structure, perfect data model. The only thing missing in Java is we have no persistence for our objects. And EclipseStore adds persistence to Java. And then we are able to deal with all types. We can build object model freely, and we can store it. This is the perfect combination. And with the Java Streams API, we are able to search object graphs in memory very fast. So mostly we will talk about microsecond search time. So even if you search terabyte data in memory, so imagine you have a big memory machine, 1 terabyte memory, you load the whole database in the memory, or half of the database. You have a very complex object structure in your graph. For instance, you use circular references. Even with Java Streams, you will be able to search it in microsecond. Mostly. So it depends, of course, on the complexity of your model and how your queries look like. But mostly you will reach microsecond. Promise. This is the performance of Java. And by the way, the JVM matters. So there are differences between the JVMs itself and the Java versions. The latest Java versions are the fastest. It also depends on the use case, but you should check out the JVMs and compare the JVM performance. You can probably accelerate your in-memory data processing by choosing the JVM from 5 to 15% probably. So you should check this out. So you can speed up your database applications by just changing the JVM. So great performance, and the functional principle of EclipseStore is called system prevalence. This is an architectural pattern. That's pattern is very simple. So just load data in memory and process data in memory with Java. No more database operations behind the scenes, just core Java features, search with Java Streams in memory, and then you will have a very fast application. And this functional principle, or this architecture, is already used by many companies out there for many years, very successfully. for instance, online banks or banks general use it for creating their high-frequency trading applications. So high-frequency trading applications need microsecond response time, microsecond query time, and databases can provide millisecond response time, millisecond search time. So with pure Java, with this pure Java approach, they are able to reach way faster trading applications. We have seen several systems before, customer systems. Mostly they build a Java monolith, so don't care for memory, buy a little bit more memory and build a Java monolith, and then you have the fastest machine on the planet. But there are some cons, some challenges with this approach, banks using this approach, they have to build their own in-memory database, and this is of course expensive and effortful. So this will not work for business applications. So if you have a trading system and you will earn $1 billion with this application, then probably you can build your own in-memory database. But for common business applications, this is way too expensive. Now with EclipseStore, you don't have to build your own in-memory database. Now you have a framework that provides you almost everything you need for building such high-performance applications. It is not a kind of like proof of concept or research or a new open source project, and we want to see how it works. So it is already stable and bulletproof already. It is a part of other frameworks like Helidon. So we are very proud of Helidon integration. So it comes with Helidon, and it was the first framework that uses EclipseStore. It is a modern microservice framework, microprofile-based framework driven by Oracle. EclipseStore is also part of Micronaut. It's well integrated with the Micronaut framework, and we have integrations also for Spring Boot, and more and more application frameworks are using EclipseStore as a persistence option. The history of EclipseStore is started in 2013. 2 years later, we used the framework for the very first time in production. And as I mentioned, since last year, it's an Eclipse project. And currently we work on an indexing API, and we have distributed applications or a concept for distributed applications already built. So let's talk about the architecture and the functional principle of EclipseStore. So as I mentioned, we keep data in memory, or we load data that is needed in memory and restore our object graph in memory, and we search and filter on our object graph, and EclipseStore cares for persistence. EclipseStore provides, or the core of EclipseStore is a serialization framework that was written especially for EclipseStore, and it's now also an Eclipse project. It's called Eclipse Serializer, and the Eclipse Serializer generates a binary representation of your object graph. So why didn't we use Java serialization? Why did we invent a new serialization frameworks? There are various serialization frameworks on the market. So the reason for that is the Java serialization was too insecure. too slow. We were not able to store and restore subgraphs, and storing types is also challenging. So you always have to implement serializable, and all the other frameworks on the market. Either they are based on the Java serialization, or they focus on a special use case like human readable formats like JSON, and the binary format is better for storing higher complexity. So this is not, so JSON is not suited for high complexity like circular references in the object graph. This is provided by the Eclipse serializer, and so the depth of your object graph is also not limited, so you can build whatever you like, and EclipseStore will be able to store it. The Eclipse serializer is also under the EPL license, by the way. So let's jump back to our JPA architecture. What changes in this architecture? So here we can see we have a JPA architecture, object relational mapping framework like Hibernate, local cache, our object graph in memory, and a data storage or a relational database. So with EclipseStore, we replace Hibernate with EclipseStore, or data conversion that is needed when you're dealing with a NoSQL database. So this is replaced by EclipseStore. So now let EclipseStore store yours. With EclipseStore, we keep data in memory. This is the reason why we don't need a local cache anymore. So we can skip the local cache. And so we reduce the complexity of our architecture. So here we still see a relational database. Sorry, no, we replaced the relational database with a data storage, with the binary data storage. As I mentioned, this allows us now to load data that is needed in memory, search and filter with Streams API. We have performance demos that prove that is way faster than a comparable Hibernate query. So it can be even 1000x faster than a comparable JPA query. And this is just Java Streams API. Christian will show a demo, I guess, later on. So again, what are the components that are delivered by EclipseStore? We have the Eclipse serializer, which is the core of the EclipseStore framework. Then we have the EclipseStore persistence implementation for JVM, and we also have an implementation for Android. It's pretty much the same framework for Android. And another reason why we developed a new serialization framework is it cares for your schema migration. It cares for what is if your classes change. So we call this legacy type mapping. This is covered by the framework. And also important topic for this training today. We have a file system garbage collector that cleans up your storage and reorganizes your storage behind the scenes. File system abstraction. This allows you to choose your storage target freely. So your storage can be everywhere, can be in the cloud, on mounted volumes, can be a S3 bucket, whatever can store binary data. And this is the reason why we also provide database connectors. This is sometimes a little bit confusing for users because why database? Why connectors for databases? It's because conventional databases can also store binary data. So you can also keep your database and use it for storing the binary abstraction of your object graph. We provide a REST interface that allows you to browse through your data in the storage, so inside the storage. And we have also a graphical user interface where we can browse through your storage. But keep in mind, this is not an administration tool. It is not built for changing the storage data, because you would destroy your database. We have native backup functions. You can use the backup functions of a cloud vendors or a database, but you can also use the native backup functions. And we have CSV import export for migrating to EclipseStore and vice versa, migrating from EclipseStore. So this is an open system. As I mentioned, EclipseStore runs wherever a JVM runs, desktops, on a server, on-premise, of course, in the cloud, in containers, in Kubernetes pods. It even runs with GraalVM native images. And the only requirement is Java version 11, so we have to update this slide. It runs with also with all JVM languages, GraalVM native images, and here we can see an overview about the database connectors we provide with EclipseStore. So just a second, please. So very important, again, you can use it with any memory size. So if you have, it always depends on the use case. If you have 1 terabyte memory or even more, use it. It's because you can load the whole database in the memory, then this will be the fastest approach, because you will save I/O operations, and I/O is always the slowest part of a system, and it's the same with EclipseStore. But it runs also with small memory sizes. It runs even with serverless functions like Lambda. So even if you have only 512 megabyte memory, it will work because the framework provides lazy loading. So you only load data in memory that is urgently needed right now. And you don't have to care for memory management. So the JVM cares for that. So this is very convenient stuff. All right. If you want to get started, it's very easy. It's a Maven dependency, and then you're ready to start. And the only thing you need is an instance, so an EclipseStore instance and a root object. You need an instance of your storage target, and you need a root object. So this is a little bit similar to a swing tree. So don't know who of you has or grew up with Java Swing programming, similar to a J tree. So you need a root object, and then you can add any kind of object to this root instance, and this is the starting point of your database, and this can be persisted by using EclipseStore. So let's add an object like a value or a simple list to the root object. This can be stored just by calling one store method. So very simple. And when we call the store method, then a binary file is generated and is stored to your files, to your file storage. And it is stored appended to your file storage. So let's create some more objects, store it, and then we will create another binary file in the storage. So each store is a new file in your file storage. So it's store dependent. The more objects we generate, the more files we generate in the storage. But this will be optimized and managed by the framework behind the scenes by the garbage collector process. Important also, what happens when we start an application. This is very interesting. So when we start an application, of course, we have an instance of our root object, and then the whole object graph is loaded into the memory, but only the object IDs. So it's kind of like indexed object graph is generated behind the scenes. So only the object IDs. This is in total very small. No data are loaded. So now it depends on you. Do you want to preload data also at startup time, or you want to load data with lazy loading just when data are needed? This depends on you. So we can load data by just calling the get methods. So get customer, for instance, and then the object reference is loaded. The objects are merged into the object graph automatically. So there are no more classic selects. This is fully object-oriented and very convenient. You just have, when you want to use lazy loading, you just need a wrapper class. That's it. No interfaces to implement. So this is very straightforward, very easy to use. Searching and querying objects by using Streams API and then legacy type mapping. But this is a topic Christian will probably cover a little bit later. Garbage collection. If you have schema changes, so you change your classes, this is handled by the framework. You store your objects again, then you have different versions of your object in the storage, and the garbage collector process will remove the older objects from your storage and cleans up your storage. So this is a very important feature and part of the training, I guess. Okay, IO operations are the slowest part of EclipseStore, but we provide a concept. It's called channels. So you can use multi-threaded IO operations. The more cores you have, the more channels you can use for parallel IO operations to speed up your IO operations. And if you use plain files, this is the fastest approach for storing and loading data, because there's nothing in between. So this is almost the speed of your hard disk drive. S3, of course, is way slower. If you use databases for storing the binaries, it will be slower, but it depends on the use case. Replication is not a part of this training, but to mention, it is possible if you want to build distributed applications or microservices. MicroStream provides a concept it's called replication. Provides an EclipseStore cluster approach. This functional principle is also very simple. There is one writer node, and you have multiple reader nodes. You can configure that very easily, and all store operations are delegated by the load balancer to the writer node. The writer node stores your object persistently on disk and distributes the store operation to all replicas. This concept is eventual consistency, and it's built for read-heavy applications. And the MicroStream cloud provides you elastic scaling, so that your system is able to scale out and scaling fully automated, very easy to configure just by some mouse clicks. And then you are able to run an EclipseStore cluster. So you can see the cluster architecture is very simple. You only have the application nodes or your microservice nodes that scale horizontally, and then you have a binary data storage, and that's it. These nodes are stateful, but you can also use it with stateless applications or stateless microservices. Then you can query the EclipseStore cluster by using REST or GraphQL and use your EclipseStore microstream cluster as a data provider. So this is also basically possible and very easy to use. Here is an overview about the products of provided by MicroStream. So the core, of course, is EclipseStore open source technology, and we provide a advanced search index API and fully automated lazy loading concept, and the EclipseStore cluster solution on premise and as a service, software as a service at AWS currently. So we are almost done. Challenges with EclipseStore. This is also important. Only the challenges here are missing. Yeah, so the biggest challenge actually is EclipseStore is not a database server anymore. There is no more database server. Everything is executed in memory. It runs within your Java, your JVM process. So you have to search and query always in memory. There are no more classic select hitting a database. There's no more cache in between. So this is a paradigm shift in database programming. And there are, of course, some database concepts are missing because it is not a database server anymore. But we believe this is not a problem because mostly these missing features are covered by the business logic anyway. So validation, concurrency handling, you have great features, core Java features for concurrency handling, and mostly validation, logging or locking is mostly provided by the business logic anyway. It's because in Java we can do it better. It's tailored for the use case, so we don't miss it with EclipseStore. But it's missing, and we should mention that this is missing. It's also can be a challenge in terms of your organization, because probably we have some DBAs, and DBAs will not be happy with EclipseStore because it's built for Java developers only. So Java developers just have to change the class, and then you've changed your model, your data model, and there is no more database side data model controlled by DBAs. So, and searching for issues is done by Java developers. So there is no job for DBAs anymore. And this it sounds funny for Java developers, but because we like it. But this might be a problem in some cases, in some organizations where you have a strong DBA team. So this can be challenging. Hot discussions with your colleagues. It's built for Java only, so it is not suited for all programming languages. So we are planning implementations for .NET or other programming languages, but they are not here already. Yeah, and it's not a drop-in replacement. So because it works fundamentally different to Hibernate, fundamentally different to a relational or NoSQL database, it is not a drop-in replacement. There is a migration effort. This is mostly not a problem, and mostly you can keep all your classes, but keep in mind you will change your object model because you can do it perfectly with EclipseStore, tailored for your use case, and you don't have to care for a database system. All right. that's it. In a nutshell, the functional principle. If you have any questions, I will answer your questions in the chat. And I'm happy for questions. And now I'd like to hand over again to Christian. Thank you for joining, and have a great training today. Thanks.
Okay, thank you, Marcus. So you should see my screen again. So my IDE. And there was I want to step into one question regarding the use cases of EclipseStore, and yeah, it's always interesting to explain that. I would say, in my opinion, EclipseStore could be a replacement for any relational database on the market, or for 80% of all relational databases or NoSQL databases on the market. You might say, okay, what about the other 20%? Well, it depends on the amount of storage which is in that database. Let's imagine we have a relational database with more than, let's say, 10 terabytes of data in it. But I would say the truth is something in between, because you will not need that 10 terabytes in that high performance like EclipseStore provides. So that means there are binary data or archive data, whatever. And then the truth is, maybe for 10% of the data it makes sense, or for 20% of that data it makes sense to use EclipseStore, because this is the data you really need in that high performance. And for the other, you could choose an AWS S3 bucket or something else. I think that's exactly the point. So, but at the end, we are able to say, okay, you will be able to replace any database on the market with EclipseStore, because it's a fully database, I would say a data storage solution with it's a different approach, but yeah, it's made for that. You could use it as a caching solution also. Whenever you use caching or whenever you use microservices and you need smaller storages for sharding, for example, use it. You could use it on desktop applications for storing things on a desktop application without heavyweight databases at the end. And this is exactly how we use EclipseStore currently on our customer projects. So we changed a few projects already on the Allianz Insurance Company, and we're also working on changing or migrating from a huge Oracle solution on the Frankfurt Airport. Yeah, to migrate this to different, I would not say microservices, but to different modules to replace that big monolithic things within the architecture. And I think that's the point. So you could use it for many different, there are many different use cases to use EclipseStore at the end. Okay, so no questions so far. That means I will directly step into the coding before the break. And the first part is just a demonstration. So that means lean back and just have a look. I will explain every single detail in that example. And after that, you will be able to code along with me. So, and yeah, let's start, I would say. So I created a small Java project here, which is called basic example. By the way, this is the only project which is not available via GitHub, but all the others, they are. And let's start at the dependencies that we need. And the only thing we need is this small dependency, which is called storage embedded. It's not the newest version, but it's okay. There was also that question, what are the names between EclipseStore and MicroStream? What are the differences? And as I explained, MicroStream was the product name before we donated it to the Eclipse Foundation. And it changed to EclipseStore, but the API stays, yeah, I would say it stays the same, except some imports that has changed. But yeah, at the end, it's totally the same. So the code base. Okay, so as I said, we need a dependency, which is the stored embedded dependency. There are some more but I come to that later. Okay, that's it. So that's the framework itself. And let's jump directly into my main method. And I always say it's, yeah, you only need a few lines of code, let's say 5, and you are good to go with your storage. And this is exactly what I want to demonstrate here. It's the first line we need is we need our embedded storage manager. So that that's the, yeah, I would call it the, yeah, let's call it the database system itself. Everything is managed within the embedded storage manager. Let's create the import for that. And this is one way to initialize it. So we call start. And on top of that, on top of every object graph we want to store, we need one root object. Now, some of you might ask, okay, is there a possibility to have multiple roots, or is it possible to have multiple storage manager? Yes, both is possible. That means you could have multiple storage managers in one application, and it's also possible to have multiple roots. If it makes really sense to have multiple roots, I'm not really sure about that. Most of the time, I'm using one root, and I'm totally fine with that. So that means in that specific case, I use a string as an object because it's an object like all the others, I just want to store that string. That's a very basic example. And at the end, I have to call the store root method. And this is sometimes a little bit confusing. This is the same example like we provide within our documentation. I would not recommend to use that store root method all the time. I will explain you that a little bit later, why not, but in that case, it's totally okay to doing that. And that's it. So that means we created a storage manager. We set one root object on top of an object graph. In our case, it's just a string. And then we call store the root object. That's all we need. Let's make a sys out at the end, and let's start the application. So let's run it as a Java application. Oh, just a second. There is, we have to do a Maven update before. Let's say, okay, so we don't need that anymore. Okay, let's try it again. We forgot to shut down the application. Okay, that's why. I'm just wondering. Okay, but anyway, what happened now is it creates the storage folder itself. So in my situation here, I choose the normal file system as a storage target because this is the default behavior. And you could see that, or you will see that on the left here, it creates a storage folder, and that storage folder contains the most important files, I would say. Let's jump in that folder just to show you what happens there. Show in System Explorer. And now let's jump into that. So you see, this is the folder itself. And it consists of these two files. The persistent type dictionary. Yeah, let's say this is all the types which can be handled by EclipseStore or which are handled by EclipseStore are registered in that dictionary. And the channel 0 file contains the data in my case now. And this is what Marcus already said. We are able to create multiple of these channels here. And that gives us the possibility to write down to the file system in a multi-threaded way for each channel. But in my case, one channel is totally enough. It's just a small demonstration. And yeah, it is like that. So okay, so now what happened when we we set the root hello world, and this is how it works. Now let's change that a little bit. So we don't need that anymore, and we keep the shutdown here, and we create our first object, which makes more sense in my opinion. Let's say this is our root object. So let's say we are a book selling company, whatever, and we need a company on the top of as a root object, and this is how it is handled here. So the company object is already created, and you see that here now the company itself contains a list of customers, and we need those get methods and maybe setters, but it's not needed here. Let's jump back, and we create the same. We create the embedded storage manager in a different way. Oh, come on. So, and we say start, and we directly hand over the root object, and we say that the path should be a folder named data on our file system. No longer storage. So now we name it data, and now we have to create a few customers with a name and so on. Let's jump quickly into the customer. Now, this is also quite interesting. You see that these are normal domain objects, nothing special in it. You don't need any annotations to make them or to make them move or serializable, whatever. The EclipseStore serialization is based on our own invented serialization, so there is no annotation needed. Yeah, it needs a normal domain. It needs to be a normal domain object, and that's all. Okay, so we created those customers with a name and an email address, and we have to add these customers to my company. So that means give me. So I called the collection itself, and I added the customer at the end, and I have to store the collection itself. And this is one of the biggest thing you have to know when you work with EclipseStore. You always have to store the object which has changed. So that means, or you have to store the reference holder of the added information or whatever. So and in our specific case, we changed the collection itself because we added some customers, and that's the reason why we have to store the collection. And yeah, or the collection is the reference holder of these two customers, and that's why we have to store the reference holder. At the end, we call storage manager shutdown, and that's it. So let's store this, and let's start the application. So that's it. Let's do a refresh here, and you see this is the data folder. And now we could have a short look to the persistent type dictionary. You see that here, this is what the type dictionary contains. You see each object has its own object type ID, and especially you will see your customer, which is created. Our own customer object is already there with a specific object type ID. And this is how EclipseStore works in the background. So each entry of the binary part consists of an object type ID and an object ID. And this is how EclipseStore works in the background. This is a quite important file. You should not lose that file within your store, or you will never be able to recreate your storage if you don't have that file anymore at the end. Okay, persistent type dictionary. Let's see if these two customers are really stored. So what else do we need? So this is, we no longer need this. We don't need this. And we don't have to store it, right? This is all we need, but we need the system out at the end. So let's do it like this. Let's call the storage manager here. Let's say storage manager dot, give me the root. Okay. let's do it like this. So we have my company as a root object, and give it a customer, and let's say stream dot for each. So let's create a C for customer. That's it, and let's do it like this. System out c dot get. Give it a mail address, just to ensure that we can see the entries here, and they are stored in the end. So let's start that application. So now we have to find our two entries. You see that here, and this is how EclipseStore stored the things at the end. So automatically on startup the embedded storage manager, EclipseStore looks at these that path here, and it loads the data automatically from the file system directly into the RAM. And from now on, we are working completely within the RAM and on your object graph, and that's it. This is a really easy and straightforward example, and this is just to explain you how EclipseStore basically works. So it's quite easy. Any questions so far? Let me just have a look to the chat. Over there is a lot of stuff going on. Okay, but most of the time Marcus wrote, okay, there is a new one. Why don't you lose the data? I created at the first, let's do it again. So let's delete data and storage, right? So I deleted the database. Now I deleted the files on the hard disk. So I created a storage manager. I created the two customers here. I added the customers to the my company object, and my company is the root object. Okay, so and the root contains a list of customers. So that's why I added my company there. I added the two customers to that company object, and at the end, I said to the store manager, please store that collection my company.get customers, and that's it. So this was the first try. So let's start this. The objects are created at this run. So it's done. Now I'm able to delete that. I need that no longer because the data is already stored. So you see that here the database is created. You see here is the data folder with the channel file, persistence type dictionary, and so on. And we don't need that store anymore. Data is stored, and on startup of the storage itself, the data will be loaded from the hard disk, and you will be able to load it directly from that object. So let's test this. Let's say run as Java application. And now you see here are the two entries which are stored in the previous run. Does that answer the question a little bit? Yeah, that is totally okay. So you could have it doesn't matter what is part of my company. You could add some thousands of different data types and lists and hash maps and whatever. All that stuff will be stored at the end. It doesn't matter what type of data is within your storage. EclipseStore supports, I would say 99% of all Java collections and objects and whatever. It doesn't matter. We will also be able to I would say it's the same like storing a customer itself, right? So the customer itself consists of normal I would not say primitive data, but strings and local data and so on. It's nothing different than to have these elements also within the my company object. That doesn't matter. So you could have any objects or on any type of objects within your graph. That except third-party objects. I would not recommend to add third-party objects because of some other things. I'm talking about that later on. But the basic Java stuff, you could use everything from Java. Okay, let's move on a little bit. Maybe that helps you better. The next example helps you to understand it a little bit more. Let's start with the step-by-step configuration. And this is the first hands-on project I want to start with you. All of my projects are Micronaut applications, because that enables us to create some controllers and to read the data and write the data and so on. That makes it easier for me to create examples and to work with that examples. Otherwise, I had to create some UIs or stuff like that. And that's why I choose Micronaut all the time. So let me share that repository with you. Just a second. Step by step. Yeah, that's the URL. Okay, this is the URL of that project. I already opened that project here on. You could choose any IDE of your choice. That's totally up to you. Just clone that project from the repo and open it or import it to your IDE. The only thing you have to do is you have to enable the annotation processing of your IDE. That is needed when you use a Micronaut project. Within Eclipse, it's part of Maven here, and we see there is the annotation processing, and in my case, it's on experimental. That's enough. I'm not sure. I'm not really sure how it works within IntelliJ, but I knew there is this type of thing is also available within IntelliJ. You have to enable this to make Micronaut working within your IDE. Okay, just clone that. And there is one branch which is called beginning. So this is the branch we start. And let's create an application from scratch with EclipseStore. You see there are no folders in it, and you should be able to stay on track. I will do it quite slowly to keep you on track. But if you lose, then just jump to the next branch, and you can go further with us or with us together. So yeah. I will give you 5 minutes to set up your IDE, to clone the project, and yeah, to import it and so on. At the end, you should start on the beginning branch. There is one file which is called application, and when you import that project, and when you on the application here, you will be able to run as a Java application, and you should see stuff that looks like this. So when you start the application, by right-click within the application class and say run as Java application, you should see this within your console, and you will get the message that the server is running on HTTP localhost 8080, I guess. So yes, maybe that's different on your, and when we call that localhost 8080, we should see, yeah, it looks like this. Just an empty page not found. That's what it is. There is nothing, no controller classes available so far. Let's start. This is also an interesting part, because as Marcus explained, EclipseStore is always bind to each virtual machine. That means you could only access EclipseStore within your application itself. And many people always ask, okay, what if some more applications need to access data? And this is, I would say this is asked all the time. So, and we recommend to do it exactly like this, creating a data provider application, which is, in my case, it's made by Micronaut. So that means you create your own database in a way, I would say. So to provide the data to different consumers, I would say. And that gives you the possibility to split up the database a little bit, to shard your database. You could create one module which provides the customer data, for example, one module which provides orders or whatever. And that makes your application or your database or your data at the end much more scalable and much more flexible than just having one monolithic database somewhere. And if the database is not available, application is not available. So with that approach, you will be able to have smaller, don't call it microservices, let's call it modules or whatever, or let's call it data providers at the end. And I would say this is best practice for years anyway, to do it like this. So I knew it's different. A lot of people are accessing one storage from multiple applications, and yeah, it is what it is. But best practice has never been best practice. We always tell people to creating services, to providing data via REST, for example. It makes more sense in the end. Okay, so give me just a second. I have to prepare that a little bit. Okay, so let's see if I write the main. So just have tried to find. Oh, what happened on me? So just a second, I have to check my repo. Something is wrong with the repository. Okay, let's switch to the right branch. MicroStream, that's also okay. Let's. Okay, so yes, now. Okay, the first thing we need when we start with with EclipseStore, sorry, we have to add the dependency. So this is the first step. So let's move to the POM XML and copy some of the dependencies. And no worries, I will copy this also to the chat. So these are the two dependencies which are needed for now. So I hope this is okay for you to copy paste this from the chat. And just copy this to your POM XML. So I will do that also. So let's go to the step by step. So POM XML. And I copy these two dependencies to my POM XML. The first one we already talked about. This it's the storage embedded. It's, I would say, the main dependency we need. And there is a second one. It's called storage embedded configuration, and that enables us to do some more configuration things within EclipseStore. And yeah, it's important to know that for some more configuration, you have to add a dependency like this. And I would say these two dependencies are the most important ones. So there is one question: can we have several Java runtimes accessing the same storage? No, it's not. There is only one storage for one JVM. So we are working on a second solution currently that is able to doing that, accessing one central storage for multiple, let's call it. Yeah, I'm not sure if the pods are then real replications. I would say not, but yeah, we're working on a solution that works like this, but not now. So only one JVM is able to access a storage in the end. That's why I told you that with the data provider server and those stuff. Okay, you added the dependencies, and that's all we need to do within the POM XML. Let's close it. We no longer need that anymore. And let's move on. We need one class to initialize EclipseStore. And some of you might say, okay, this is not the right way to do it within Micronaut. The point is, I used Micronaut, and this is also a question from you. You're always asking for integrations within Micronaut and RDBMS and so on. Those integrations are available, but you will always be able to create your own, normal integration. And that's what I want to do. I just want to show you how to initialize EclipseStore at the end without bringing you that much Micronaut stuff. So it's not a Micronaut training, it's more an EclipseStore training. So I'm doing things different at the end. You will see that. So let's create a database class. Let's create a new class, call it DB. It's just a class to initialize the objects we need. And within the DB class, we create these two most important objects at the end. So, and I'm doing this in a static way. And as I said, I'm aware of this is not the way to do within Micronaut, but it's just as an example. So let's say public static, and let's call it embedded. This is the embedded storage manager. So embedded storage manager, here it is. And let's call it storage manager. And a second object which is needed is the data root object. And we have to create one. Let's create a new object or a new class and call it data root. And this is also a question all the time. What if there is no business object on top, or what if there are multiple business objects on top and there is not only a single root like a company in the example before? Then let's use just an object, call it data root, and this is the entrance. This is the main entrance to your object graph. It doesn't have to be a business object at the end. So just create. Let's create an instance of that data root. Let's say public final static data root. Let's call it root, and let's initialize this new data root. Okay. These are the only things we need. And now let's create a static block just to initialize. Come on. So, okay. And let's say storage manager equals now, and this is my personal favorite to configure an EclipseStore. I will use the builder pattern in that case, and let's use the embedded storage configuration. And this is the reason why we had to add that second dependency to get that builder pattern. And now we could call builder, and now we are able to say dot, and then we say set storage directory. Set storage directory. Storage directory. Let's call it data. So we want to store it somewhere. It could be a persistent volume. We use persistent volumes and file storage most of the time, but there are several combinations available. So we use a persistent volume as the main storage, and we use an S3 bucket as a backup solution, for example. Or we use S3 bucket as the main storage, and I don't know, a database as a backup storage. There are many different combinations possible. It's totally up to you. So for now, we set the storage directory, let's call it data, and based on that configuration now, we don't want to configure some, or let's add some channels. Let's say set channel count, and let's use 2 channels. That means whenever we access or whenever we write down data to the file system, we do it within 2 threads, and let's create 2 channels two channel files based on that. And based on that configuration, we are able to create an embedded storage foundation. And based on that foundation, we create this embedded storage manager, and we have to hand over the root object, and then we call start. And that's all we have to do. So we created the builder. Based on that builder, we added some configurations. Based on that configurations, we create a foundation. And based on that foundation, we create the storage manager, hand over the root object, and at the end, we call the start method. That's all we need. So I initialized that the static way. That means whenever I access that static DB class, the storage manager will be initialized at the end, and the storage is up and running when I access the DB. Okay, any questions so far? Okay. So then we are done with that branch. Let's jump to the next one. Oh, I mean, that's interesting. Good to know. So I will check that directly. Okay, let's move on within that example. We need some domain classes. I will create another package. Let's call it domain, and add some domain objects. Let's choose a book. Let's call it book. And another one, which is called author. So let's create an author object. Okay, here we are. So 2 objects. Let's add some fields in it. So for the book itself, we just need 3 fields, I would say. Let's create a private string. Let's call it ISBN. Another one, private string name. And private author. Wrong class. Thank you. So let's copy this to book. Thank you. Okay, this is the book. So let's create some get and set methods. And that's all we need. On the author class, so we also create 3 fields. Let's say private string mail and private string first name, and of course a last name. Also get and set. And that's all. Okay, now we have to create, we created the domain object itself, but we also need a collection to hold these objects within the graph. That means we have to create a collection here, and let's use a private final list in that case of type book. Let's call it books equals new array list. Let's import the book itself. And let's create some get and set methods. Yes, it also works with Lombok. Yeah, it's no problem. To be honest, I never used it before, but I knew from my colleagues that they used it, and yeah, this works. Okay, so we created the configuration and the instantiation of the microstream EclipseStore storage itself. We created some domain objects and also the root object, which contains the collections and the books and the book. And this is the first step, and I want to explain that a little bit. That makes the object graph a little bit different to like on relational databases. You always have tables of each object, I would say. And within EclipseStore, it's different because there is no collections of authors in the end, and in that specific example, because authors are part of my book. So each book has its own author, and there is no list of authors needed for now. So that means each book comes with its author, and we are totally fine with that. Okay, so now we are done with the branch entity and register. That's it, branch number 5. And now I switch to the branch number 6, controller create books done. This is the next step. We need one controller class to provide the data at the end. Yeah, let's do this enough, and we have enough time to create that at the end. So we create one another package. Let's call it controller. This is where the REST interfaces are created. And we need to create one book controller. New class, let's call it book controller. Okay, and we want to have only two interfaces. What we need is to mark that class as a controller class. We have to add the annotation add controller. And it's the HTTP annotation controller from Micronaut. And we said, okay, we want to call it via /books. And then we have to create two methods. And let's do this by creating a method, call it public. And we want to return a HTTP response from Micronaut, and let's use a string within that, and let's call it create books. Create books. So we need to create some books to see what happened within the storage. On top of that method, we need a get, of course. This is a get method, and we say, okay, /create is the path we use for that method in the end. And you might say, okay, this is not a real get because we're creating some objects there. It must be a post and whatever. Yes, you are basically right. But as I said, I try to keep it as simple as possible, just for you to make it possible to call it from the browser. That enables you to call that method directly from your browser at the end, and makes things easier, things a little bit easier at the end. Okay, we created that create books method, and we need another one to list books. And this is also quite simple. Just use that get, and then we call public list. We return a list in that books and call it get books. Let's call it get books. Yeah, here we are. Okay, so we need some parts within the methods, and I just copy paste this to save a little bit time. So, and paste it to the chat. So that enables you to copy that. Just copy this to your code. And it says that we create, I missed the so we need some more, we need a special constructor for that. So within the author, we need the constructor with the fields, and it's the same on the book itself. So just create the constructor based on the fields. And I just want to double check there if we also need the default constructor, but I guess not. So that's okay to use it like this. So just create those those field constructors at the end, and then it should look like this at the end with no errors. And let's jump back. Okay, so and now we need to store these objects. So let's call db.root books. So just remember, when we call root, we get back our root object, which is hand over here. So this is we access that root object. get books, so that enables us to get access to the collection. And then we say add all, and then we use the collection or collections dot set off, or what is it? Collection utils. Okay. Collection utils dot set off, and that enables us to add a book and book 2 and book 3 and book 4. That's it. So that means I added these books to the book collection, and I have to store it because I changed the book collection here, and that's why I call db dot give me the storage manager. Whenever I want to store something, I have to go to the storage manager, and let's say store, and I have to hand over the object which has changed. So in our case, the book collection itself. Can there be a back relation of authors? There is one question in the chat. Yes, it could, definitely. So EclipseStore supports circular references without any problems. So just create as many back relations to author as you want. In the end, you have to deal with it yourself because you have to add both sides all the time. But in some parts, it's the same on bidirectional objects within Hibernate. It's kind of like the same. You always have to deal with both sides, especially when you use caching and stuff like that. Then I would say it's the same. Okay, we need to add a return. So let's return HTTP response dot OK. And let's say books success created. And last but not least, we have to add a return down here. And this is quite easy. We just add db.root.getBooks. That's all we need. Cascade type operations are not supported by default. You can do it. Yeah, so that's not that easy to explain. When you remove an object, which is a top object of some more or some others, and you remove that one object, all the stuff below is also gone. So that means based on the references, when you remove a top object, all the stuff below is also gone. So yeah, it's cascading in a way, but you have to take care about this. It's not an embedded functionality of EclipseStore at the end. I hope that answers the question a little bit. Okay, so I would say we are good to go. Let's try to start this, or let's try to start. It should be, everything should be fine. So let's jump to the application class. And for those who are lost somewhere in between, just check out the last branch. It is called branch number 6, controller create books done. And then you will get the whole project and with all the existing implementations. And yeah, let's give it a try if I coded everything right. Okay, server is up and running. Let's go to the browser and let's call localhost 8080/books. And we should get an empty, we should get an error. But this is because I missed the Maven update. So I just have to Maven update. because I added some, the dependencies of EclipseStore, and that's why I have to do I have to build a project. Okay, so let's try it again. Okay, so let's try localhost books. Oh, again, error. What? Unexpected. Okay. So there is already a storage available, which is called data, and that was the problem. Okay. Again. Okay. Okay, slowly, but okay. Next try. Now it looks good. Okay, first mistake was there was a storage already available here, and this storage was with only one channel, and we created a storage with two channels, and then it says it's not compatible to that storage. And the second time, I started the application twice, so the port was already in use. So I called the book method, and it's empty. Let's call the books/create. Then books should be created in the background, and we get the message book successfully create. And when I now call the books method, we see the data that comes directly from the database itself. And even when we restart the application, so let's stop the application and let's start it again, we should see the same result. So let's call localhost books. Now you see the data without creating it at the beginning. So we had a question, do we also have events like post or pre-CRUD like ORM have? No, not. There is also not, this is not an embed functionality. I would recommend doing that on your writing your own methods for that. So whenever you create an object or within, so in my case, I always create some I always call it DAO data access objects with some data access methods, and within that methods I create those post pre stuff. Then it's a good central place to add this functionality. I think that's the different mindset of EclipseStore and all the other databases. EclipseStore itself, it's just a storing framework. So just to enable you to store data directly to your data or to your hard disk, for example. All the other stuff is part of your business logic and is just pure Java. You could add everything that is that you want. On restart, I get an error from micronow double free or corruption out. Okay, that's interesting. Could you check if you maybe there is maybe the application is still running based on the port, maybe. Not sure, but maybe the port is already in use, but I've never read that. Okay. Get an error on restart. That's interesting. So why I'm getting memory access double. Okay. Okay, which JDK? So I used 17. I use JDK 17. It's you have to use JDK 17 with the newest version of EclipseStore. Okay. Oh, interesting. So, try to up. Maybe that could be. Okay. Try to use a more. Try to upgrade your EclipseStore version. We started with 1.0.0. Just use 1.3.2. That should solve the problem at the end, because I knew that there was a JDK bug on 21, and we fixed that with the newest version. Just use the newest version 1.3.2. That should solve the problem. Of both dependencies of EclipseStore. Both EclipseStore dependencies, storage embedded and storage embedded configuration. Just use the newest versions, or the newest version. It's when we have a look to the EclipseStore documentation. So this is the newest version of storage embedded, and also on storage embedded configuration, and that should solve the problem. Okay, does it work for every one of you? Or do we have some more questions? So as I said, it's a really straightforward example. Just to give you an idea how it basically works. So, and in my opinion, it is really easy to use it. I will move on to the next project. This is an example project just to give you an idea how all the different CRUD operations are working. So the create, read, update, and so on. Just lean back and have a look to the project itself. I will share the repository again with you. It's just a second. So this is the URL to the CRUD operation project, and this project also contains multiple branches, 2, I guess. So let's just double check. Yeah, there is the master branch itself. It's an empty branch, and we directly start at the CRUD implementation done branch. It makes sense because I have to speed up things a little bit to get all the topics within the training. Okay, let's directly jump into the project itself. So it's basically the same project we created before. You see here within the DB class, I created the storage itself based on existing XML file. That's also possible. So that means I load the resource here, and based on that resource, I create resource.get path, and based on that, I create the embedded storage foundation. And this is also one additional possibility to initialize a storage itself. And there are many more. And we talk about this on the Advanced 1 training, all the different types of initialization, also within Spring and within Micronaut and so on. But that's part of the Advanced 1 training. Okay, so that's basically the same. Let's have a look to the data root itself. There are only books in it, and it's the same data structure we had before. with books and authors, price and big decimal. That's a little bit extended, but nothing special at all. I think the book controller itself, it's the most important or most interesting class in that project. And it's the same here. I used the get methods on all the interfaces because it makes it easier for you to call it within the browser. In some later projects, I also used post, and you have to use a postman or stuff like that to call it. But yeah, let's talk about that controller class. It's the only one controller class in it, and let's go through these methods. We already talked about creation things or creating things, and what happens here is that project contains a JSON class or JSON files. You see that here, authors and books. And as far as I know, there are around 1,000 books in it with an ISBN, with different titles and so on. And within that method, load mockup data, I create a list of books at the end, and we want to store it. This has happened here. So I called the get books collection, and I add all the created books here. And at the end, as I already explained, we have to store the object which has changed, and it's the collection itself. So at the end, book successfully created. That's it. We already worked with that. That's okay. It's the same on create single. So when we create a single author and a single book, that's the same. So, and we added the author directly within the constructor here. So here we have the author object, and at the end we added that book. It's the same like the create books before, and we have to store the collection itself. Get books, nothing special. The next two, or the next method, is a little bit more interesting. This is also a question I want to talk about, because many people ask, okay, how to get the data back, or what is how to find data or filter data. And this is exactly what we have done here. We use the Streams API to filter, and as far as I know, the Streams API is contains most of the features, or I guess all of the feature SQL contains. There are no big differences between, and we're using the Streams API to filter for some data, and this is exactly what is used here. So we go to the DB get books collection, we stream through it, and we say filter at the end, and then let's give me all the books starts with an A. So this is what happened here. And at the end, I say, okay, please return a list collection at the end. And this is exactly what happens here. So quite easy, but we talk about streams a little bit later. Clearing stuff, it's also important to know how to delete a book or how to delete multiple books. This is exactly what happens here. So we call the normal Java method clear on the collection, so that clears the whole collection. And at the end, we call the store method on the collection. That's all. That's exactly. And this is, by the way, the same when you just want to delete one specific book. Just remove that one specific book from the collection and then call the store and store the collection itself. That's all you have to do. And in the end, this is how to delete stuff from the database itself. So that means there is no delete functionality or no delete method at the end. Just remove the object and that's it. Okay, update a single book. That could be interesting. So in the first line here, I tried to find the first book, and I changed the release date of the book. That means I set the current date at this moment as a release date. And after that, I store the book. Do you remember? I always said you have to store the object which has changed. In that case, the book has changed because the release date, it's a it's a local date field within the book. And if that field has changed, we have to store the book itself. It's the same on update multi. So if you want to update multiple books, and we could do it this way. Give me just a second. So let's say, okay, let's find all the books starts with an A. So it's the same filter as the filter here. And let's stream through it with a for each. And after that, we set the value of price, or we set the, or we multiply the price by a specific big decimal. It's not really important what happens here. The fact is that we change the price, and we could do stuff like this, right? We could say db.storagemanager.store, like always, and we change the book itself, and that enables us to store B, because B is the book we the book we are at the moment. So that's possible. I would say this is not the best way doing that, because storing things is always a blocking operation. So that means it makes sense to change multiple books at once, and after that call store on that changed objects. And that is possible with the way it is here. So we create we call it eager store. There is a second one, which is called, just a second. So let's create one, eager store and a lazy store. So there are two different methods here. So the eager store, let me just check if I'm right. So the lazy store, which one is the default one? Sometimes it's hard for me to remember that. Storing data, lazy eager store. Yeah, the lazy store is the default store, which is this one. And that means this store stores only the object which is handovered within the method. That means when we call ls.commit, like down here, then only the object itself it's stored. When we use an eager store instead, that means that the handover object will be stored and all the sub objects also. So that means you, for example, you have a customer object, and below that customer we changed the author, for example, and also the address of an author, and so on. Then you could use an eager store and hand over that book object, and it will store all the changes of the whole tree from there on. And sometimes it makes sense to use that, but I would recommend to use the lazy store as much as possible instead of the eager store, because sometimes it could be quite heavyweight to storing objects the eager way, because of the amount of sub objects in it. It makes sense to use the lazy store and storing more precisely, I would say. Okay, so in this example, I used the eager store for no reasons, I would say, because I just change a direct field of books, but doesn't matter. So I use the store and I use the method es.store. That means I register the changed book within that store. And after all books has changed, I call es.commit, and that that provides me kind of like a transactional behavior. So that enables us to use a try catch, for example, and doing rollbacks at the end. But this is how the eager or lazy store works, basically. Okay, so just checking. Let me just double check. Yes, yes, you are totally right. So this is, it should look like this. Yes, store B. Now it's right, isn't it? Yes, it looks good so far. Thank you. So let me just check if there are some questions. How is the memory footprint of this operation? Yeah, the point is the data is in memory anyway. So there are no object copies. So all the users are operating on the same object graph. So that means the data stays or is within the RAM anyway. So so I would say the memory is not doubled or multiplied because of that functionality. It stays the same, I would say. But you are right. So when we talk about streaming and filtering, the data has to be within the RAM, and this is exactly the point where performance comes into play. That's why EclipseStore is that fast, because it's working completely in memory. So that's the way it is. Yes, it is. There is a way to load partial graphs. We use the lazy references for that, but I have come to that a little bit later. Okay, some more questions to the CRUD operations. That lazy storing does not store an object if it has already been stored before, even if it has been modified. Yes, that's exactly the case. Yeah, I think the explanation is a little bit confusing at some points, but I think I would say it's all about the object which is hand over to the method. And in easy words, lazy storer stores only the handover object, and the eager storer stores the whole graph below, if that graph has changed, of course. If not, it stays as it is. So the point, so to understand this a little bit more in detail, is EclipseStore is an appending storage. That means, let's say we storing a customer multiple times. Whenever we, let's say we have a customer reference or a customer object, and we store that customer multiple times, or 10 times or 15 times, then every storing, it appends the whole customer, and the whole object appends to the storage itself. That means at the end, on that binary block on the hard disk, it appends that customer 15 times. And there is a garbage collection working in the background, or let's call it housekeeping process, and it deletes that double entries in the background. So, and this is also why I explained for just using the lazy storer makes more sense to do that, because sometimes it's not the best way to append bigger graphs always at the end of the storage. It increases the storage for a short time. Yeah, maybe it doesn't matter because we have enough storage at the end, but it makes more sense to use a lightweight functionality with the lazy storer. Yeah, that's right. Yeah, the lazy storer stores only the object itself, but not the referenced object below that object. Yes, exactly. That's the difference between eager and lazy storing. The default, so when we just call this one, is lazy storing. So it stores only the book itself. So that means when the book contains an author and you change the email address of an author, will not be stored at the end. So with that call. Then if you want to doing that, you could do something like this. Let's say store all. That could also be possible. And then you could say book.getAuthor. That's also possible. This will store your book itself, the book itself, and the author, which is referenced by the book itself. And I think that's all of the store things you have to know. There is a store method, a store all, and then we are able to create some eager and lazy store. And I think that's totally enough to handle every situation within EclipseStore. The object identity, a good question. Within EclipseStore, it's just the Java references. Within the framework, we use the normal Java references to handle identities. On the business side, or on the business side, you have to create your own identifier, I would say. So whenever it makes sense to have customer ID, for example, or an ISBN, for example, for a book, that makes sense to use it. But you will not need a synthetic primary key, for example. That is no longer necessary within EclipseStore. Just create your business identifier. But I come to that a little bit later. Okay, any questions so far regarding the CRUD operations? So we talked about clearing stuff, deleting stuff, store all, store functionality, and the store methods using kind of like as a transaction. So if the same object is referenced by multiple objects, the referenced object is stored one time. Yes, that's exactly. And regarding the cascading stuff we talked a few minutes ago, it's also the same. For example, when we maybe we have a situation like this. Let's do this, and we say, okay, we need another list of authors at the end. Then people always ask, does that double the amount of RAM because of the amount of authors? Because the book object itself contains an author object, and to have another list of authors could be possible, but it will not double the RAM because these are only references. That means when you change an author here, it will be automatically changed within the book itself because it's a reference. So, and that is that is really great to handle that within the storage. Okay, let's move on. Next topic is, I think that's that's not the right one. So yeah, creating proper data model. That's exactly the point where we are. I brought just a small presentation because a lot of people also ask, okay, how can I migrate from Hibernate, for example, to EclipseStore? Or how should I create the object graph? And that's why there are some things you have to know when it comes to the data model itself. So let's create a small example. So imagine we are a book selling company with multiple bookstores, and we are selling thousands of books a day to our customer. So what most important nodes or tables do we need to, and how the relations would look like? Okay, let's go through. Of course, we need a company. So we already talked about that. We need books and authors. Of course, we need stores maybe. Then we need a list of customers, addresses, orders, employees maybe. And all these things are organized in a graph. Could look like this. We have a company, address. My company has one address, but multiple stores. Each store has multiple books, and each book has its own author, then a store could have multiple orders, multiple employees, and each employer has its own address, of course. Each store has an address, and these are our customers and addresses itself. Okay, this is really straightforward, but this is totally different to the structure of a relational database, for example, because within a relational database we have one whole table of addresses with foreign keys to many other different objects. We have a whole list of books, no matter which store has what kind of book or type of books and so on. And you see the differences directly, and this is also the reason why we do not need that much querying anymore, because we are able to navigate through our object graph, and it's not necessary anymore to do a select blah 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 for or stuff like that. It's just use your object graph to navigate through your data. And based on that, let's create an example. And what if we need a combo box of authors in the app? So this is one situation. It sounds great to say, okay, each book has its own author. That's for sure. But what if we need a combo box of authors within a specific app? So that means, let's say, when we're selling the last book of a specific author, we will lose that author, right? So the book is sold and the author is gone at the end. And this is a situation we have to take care about. And these are things we have to think about when we planning our object model. So we have to ask, where are my tables? Or what are my tables? What if I delete an object? What about indices? Let's talk about primary keys. I already answered that before, but it could make sense to talk about that at that specific part a little bit longer. Is there something else than list and set? And there are a lot of more collections we could use within EclipseStore. How about bidirectionals? Data loading lazily? We come to that a little bit later. And what are my business needs? And I think that's a really, really important thing. In the past, we always built a structure which fits best to the database itself, because we got some database tables and we use Hibernate, and we had to build a specific structure that fits best to the database. Now we are able to build a structure which fits best to the application itself. And that makes much more sense, because we could build a lot of different other stuff, which helps us a lot to handle our data. And that's really important. And it's also a question, how much data do we have? And do we have to store? And many more things to consider. And just to talk about that, let's create a small example within that project. Okay, so just a second, Okay, we already talked about this. Let's create a book object. Let's call it book. So we don't need this anymore. So this is a book class. Okay, so, and the first question is, do we need a primary key? So I would say, as I already explained, we don't need a synthetic primary key in that specific case, but it makes sense to create a unique identifier, I would say. And in case of a book, this could be private string ISBN, for example, and we are totally fine with that. What if an object doesn't have an ISBN or an identifier? One situation could be an order or order header and order details. So this is a well-known structure within databases, I would say. Then there is one problem. The order details doesn't have a primary key, right? So they have a position number, that's okay, but we never know which order detail belongs to which order header. So, and that brings us to the situation where we need a combined primary key in that case. But this is no longer needed because it's the same here within the books. Let's say the book is the order, and order details, it's the same like authors. So let's say author, it's directly part of the object itself. So that means there is no table anymore where we have authors in it. But yeah, that could be different. Create class author. Let's do it like this. Here we are. So that means our book has its own author. So what else could we do to have a unique identifier if we really need one? So it makes sense to have things like that. So we could use stuff like a UUID, for example. Let's call it UUID or UID, like this. Doesn't matter. So, and we use functionality like this, UUID dot, no, UID? Okay, moment. Here we are, private. So now, UUID dot, let's create a random one, and this could be a solution for you. And it sometimes that makes sense. Especially when we using lazy references, for example, later on, sometimes it makes sense to keep the graph smaller, not to have that many references, because when we load, I think it's not important to have this within EclipseStore because we have the data in memory anyway. But especially when lazy loading comes into play, it makes sense sometimes to cut the graph a little bit to have multiple smaller graphs, and then it makes sense to have a UUID as a synthetical reference. Could be helpful in some cases, but normally you will not need this, especially when you have a business identifier. Makes sense to use the ISBN. Okay, the question is where to store those books. We already did that. We created my company, and instead of the customer, could keep this. Let's do this. Let's call it books, and create get and set. So let's do the import and create get and set methods. Okay, so now this collection is close to the table we normally have in a relational database. And then it was that question, how to enable a combo box with authors, to choose one if we don't want to lose the authors. And I also explained this before. Let's create a second list of authors just to fill that that combo box in the end. So that could make sense to have this, but as I already explained, the question is, does that doubles the data? No, it did not, and because of the reference, and that is really great. Okay, what about indices? This is also a question people ask a lot. So another solution could be, or let's say, let's create a store. So we don't need that store. So let's imagine we have a lot of books, let's say millions of books, how to handle that. This is my basic example. It's just, so why you ask for which project is it? It's the basic example project, nothing special. I'm just trying to explain you a little bit the things that comes into play when we talk about a proper object model. So what else could we do to create a better solution instead of a list? So I would say a list is okay for, let's say, 50,000 books. Is that okay to stream through? How fast is it to stream through 50,000 books to find a specific one? So that's always the question. What about if we have 1 million books here? How long does it take to stream through and find the right book we search for? And sometimes that's, or how about a situation where we are not able to have all the books within the RAM because some of the books are more than 20 years old. It's kind of like an archive. We don't need those books in focus because those books are not used all the day. So we used it once in a month or once in a year. So we could do it like this. We could create a private final map instead of a list. And let's say let's take a string and a book equals new hash map. This could be also a great solution. So that enables us to, let's call it books 2, that enables us to create some indices to search within. Especially when we could also do things like this, the same. And then we have a list of books, a list of books. This is also a great structure, because what could the string be here? It could be the first 4 digits of an ISBN, for example, and then we have here 1,000 books in it. That prevents us from, for example, loading all the books directly into memory. Not in that specific case, because we didn't use any lazy stuff here, but it helps us not streaming through all the books, just choose directly the right key and just enter directly the right list to search within. Another possibility could be this one. Let's say instead of using string, we could use authors. A specific author could be an identifier or a key within, now I could say books by author. So and now you see there are 1,000 different possibilities to handle your data within EclipseStore, because there is not only a table anymore. You could do whatever you want within your Java structure to handle the data as that to fit fits the database to your needs within your application. And on top of that, we didn't talk about this, is lazy loading. So that means, let's say we have millions of books and we are not able to load all the books in memory. And then it is possible to create stuff like this, for example. Let's choose the string. Let's say, okay, we use the 4 or 5 letters of the ISBN, and then we doing stuff like this. We use the lazy wrapper class, and within that lazy wrapper class, all the books are set. That means in this specific case, the key, the string here is loaded to the memory on startup of EclipseStore. But the books itself stays on the hard disk as long as you call it with a get method. So books by author, then lazy books. Let's call it by ISBN, whatever, and we could say lazy books by ISBN. Yeah, I think that's the exact. Did I miss something? Lazy. Change type of lazy books to map. Something went wrong now. I can't see the mistake I made. Yeah, whatever. So I think it's important to understand how lazy basically works. That means we are able to search within the map, and after we find the right key, so we are able to access the book, and then only this 1,000 books, for example, will be loaded to the RAM at the end, and you are able to search with them. New hash map, and then yeah, that's exactly. Thank you. Now we are right. So many different possibilities, and there is another point. These two lines here. Again, the question again: does that double the storage within the RAM? No, because books are still references. We could have multiple those structures within my application, and we are totally fine with that. I think that was also a question at the beginning, to have multiple references or bidirectionals. The point is you have to take care about those lists. That means when you add a specific book, for example, you have to add it on every list, of course, and in the right at the right place, especially within a hash map, for example. You have to find the right map. But yeah, benefits are great on these structures. Okay, any questions from your side? A serial version UID of any is, I'm not sure if I get it right. Is serial version UID of any importance? You will not need this a UUID. It's not necessary to have that. There is a Java Java reference ID in the background. You don't have to take care about. It's not needed normally. Just use your normal business identifiers to find the right objects at the end. All the stuff in the background is handled by EclipseStore. Sometimes it makes sense to have that, but yeah. Okay, some more questions. Data migration, that's a good point. Now you see the different possibilities you have. Normally, when we talk about data migration, especially from, let's say, Hibernate to EclipseStore, to say it carefully, I would say, just keep your Hibernate structure as it is. Basically, it should be okay, because you have your domain objects already. You just have to remove all the Hibernate annotations. Just keep the entities as they are, and try to organize them a little bit better within a good structure. You know, you could keep your Hibernate structure as it is, and normally I would say just create a embedded storage manager directly in the same application with the Hibernate stuff, and then just copy the objects from one storage to another. That will basically work. But the point is that the structure which is created by Hibernate is not exactly the same like the structure within EclipseStore. It could differ in some points, and that makes things sometimes complicated, but basically, yeah, it's on you, it's your business logic, you have to do the migration. But yeah, most of the time it works quite easy to migrate the data. Okay, if the entity model changes. Okay, that's interesting. There is a functionality which is called legacy type mapping. It's not part of the training, of the fundamentals training, but we could jump in just a little bit, just to give you an idea how it basically works. Legacy type mapping, here it is. So I think it's more about changing things within objects itself. That means adding an additional field, for example, removing a field, renaming it, reordering it within a Java class. All that stuff is handled by the legacy type mapping. That means when most of the time it's handled automatically. So you can just add a field and it will be handled by EclipseStore in the background with that automatic mapping. Could you remember, or do you remember the persistence type dictionary? So when you add an additional field to a specific class, a new object occurs within the persistent type dictionary at the end. That means you will get a new object ID in the end. And whenever you touch an already existing object, so let's say we call a get method on a specific object, and you touch it and you store it, this object will automatically transfer to the newer version. And this is handled by EclipseStore in the background. That means whenever you have some things to change, most of the things are handled automatically. But there are some things that cannot be handled automatically. One is your question, changing structure things that could be quite difficult to handle. Or, yeah, let's say changing a string to an integer or an integer to a string value. So this could be handled, this couldn't be handled automatically. But the question is how to handle that now within Hibernate, for example, or within a relational database. I think it's the same way complicated to migrate data from different structure. And I think it's totally the same. I would recommend to just create a new collection somewhere, and on startup you transfer the whole objects from one collection to another. So just to do kind of like a migration. And we're also doing that within our projects on our customers when we have some bigger migration. So then we do the migration in the background, not on the live system. And after that, we're changing the storage itself and the code base itself. But yeah, most of the smaller things will be handled automatically. The bigger ones, you have to do it by yourself, and some migration stuff, yeah, and remapping, and yeah, that's you have to do. But I think it's the same on any other database. When you're changing structure, you always have to do a migration at the end. Okay, hope that answers the question a little bit. Especially when we talk about when you are on the development way, so there is no production version available so far, then I would recommend not to use the legacy type mapping. I always recommend create proper mockup data, use the mockup data, and whenever you change the data structure, just delete the whole storage and create a mockup on startup. This makes much more sense to have it during the development. Don't try to migrate the data during the development. Just delete it, create it again after startup. Okay. Proper object structure. I think there are 1,000 more topics we could talk about, but I just tried to give you an idea of what possibilities do we have, especially when we talk about the lazy thing here. Lazy storing is also part of the advanced again, because that topic is quite a huge topic, and there are a lot of best practices, but it's part of the advanced one training at the end. But we will step into that a little bit later also again. Okay, so let's talk about Java Streams API. This also, maybe some of you did not use the streams that much, and that's the reason why I want to show you a small presentation just to give you an idea how the streams basically works. So just a second. Yeah, Java 8 streams. Let's go through this this topic. So the basic definition of a stream, and in our product, streams are kind of like an SQL. Is a stream could be an aggregate operation to compute a single value from a collection of values. So that's the definition. The result could be whenever you stream through something, you could get a primitive value at the end. You could get an object like customer, for example. You could get a list of customers, and you could get nothing. So so that means you only process something, and at the end you don't want to have a result. You just want to process something. Or you could get an optional. That is also interesting. So that means a stream is a sequence of data elements supporting sequential or parallel aggregate operation. That is also an interesting point. We are able to aggregate sequential or parallel. That I will explain that a little bit later. And I would say it's a query language for Java collections and a modern way to process collections in easy words. So, and it's not that difficult to understand how streams basically work. And to understand streams a little bit, let's start with the easiest situations of streaming through something, I would say. And it starts with an in-stream, for example, or an in-stream.range. And it enables us to use the for each every time when you just want to stream through a specific range of numbers or a specific objects. You have to use the for each statement at the end, and then you could set a specific value for that for each iteration, and in that case we just call a sysout the y. It's the same on array streams, for example. Instead of a while alternative, so let's say we have an integer of numbers, and it's an integer array of numbers. We could use streams.of that numbers, and then we use the for each as usual. Whenever you see a for each, it's just an iteration through something, and it's the same on the collection streams. So we used that before, db.root get books, and for each book in that collection we print out the name. That's all. So just processing data, no return values. That's, I think, the easiest step into, or yeah, to streams. Let's start with the collectors. Each stream has its collectors at the end. That means whenever we want to get back some values, we have to define a specific collector at the end of the stream. So, and we see that here there is a toArray, toList, toSet collector, and you see that at the end of the stream. So let's say we stream through the books, and at the end you see the collect statement, and the collect statement defines what we get back from the stream at the end. So in this specific case, so let's say get books is a list, for example. We stream through that list and we will get a set at the end. This is a possibility, for example, to change the collection type if we need that. So I don't know if for what reasons, but it could make sense sometimes. And it's the same on the string join collector. Maybe that could be helpful in some situations. We stream through that pet list, and at the end we say .collect, and we use the collectors .joining, and it returns just a string with comma separated values. That means on every stream where we want to have an information back, we have to call that collect method at the end, or we just want to have a single value. Then we use the find any or find first. So find any means find any of that collection, and find first means give me the first one you find. Some of you might say, okay, how does that make sense? Find any should return the same than find first. It makes sense when we consider that there is a possibility to have parallel operations. That means find first means if one of that parallel threads finds a result, it will be returned. That means with find first, you could get different results when you use parallel streams at the end. And it's the same on find any, I would say. Okay, so collectors, that means the part at the end of a stream. Then when we talk about streams, we always have, it starts with the collection itself, then we have the stream keyword, and in between the stream keyword and the collect at the end, we already talked, we could add some filter methods. Let's say .filter, and we could add the name or the filter constraint in between. And there is another possibility to, and this is, for me, this is really helpful to create those predicates at the beginning. For example, I create a predicate of, let's find a book named equals Bangkok Dangerous, for example. And there is another predicate. I want to find an ISBN, which is 1, 2, 3, 4, 5. And now that enables me to combine both predicates here and say, okay, I want to find the name predicate and the ISBN predicate. And this predicate could be used within the filter statement also. That, in my opinion, that makes code much more readable than using that long streams at once. And this is quite well structured, in my opinion. So that means we have the collection itself, we call the stream keyword, then the filter comes, and after that we make the decisions what we want to have back via the collect statement. Okay, this is another point that could also be sometimes a little bit confusing. What if you want to have a specific type of as a result, like this one here? Let's say we want to have all authors from a specific list of books. So that means we stream through the books, but we don't want to have the books at the end. We want to have the authors at the end of all that books. Then we say, okay, let's stream through the books. And let's say, okay, .map, and map stands for map a different result type. And that's why we say, okay, give me C dot, let's say C is the name for the book, or C is the book itself. And then we say C dot, give me the author. And at the end, I made a decision that I collect that to list. How does the list at the end looks like? At the end, you will get a result. It is a list, and let's say there are multiple books with the author Stephen King, and at the end we will get a list where Stephen King is in it multiple times, because a list could contain double entries. But if you want to have a unique list where Stephen King is only once in it, we could change this and we say, okay, collect dot to set, for example. So map means map a different result type, or map, a single value as a list, and it's different on the flat map. Flat map, let's say some authors, in that specific case, some authors have multiple addresses, and whenever an object contains multiple sub-objects, so maybe each author has a list of addresses in it, then we use the flat map. That means we stream through the addresses, and at the end we will get a list of addresses at the end. So that's the difference between map and flat map. Map is for single references and flat map for collection references. I would say that makes sense at the end. Okay, and there are some more aggregations and stuff like that. It's not that important to talk about this. I think it makes more sense to share the example project with you, because it's always helpful to have a resource of finding all that special things. I always have to search with the documentation, and just a second, let me share the project. There it is. Let me see. Yeah, here it is. Okay, this is the URL of the project. Oh, no. I'll send it to all of you. Okay, here we are. That's the project. And there is a branch in it which is called stream implementation done. And then there you could see a lot of different streams and situations are covered within that project. So that could be quite interesting to see that. Let's just jump in. Basic example, car exercise. Here we are. So, and that's the project. Let me just switch the branch. And yeah, all these different examples I implemented for you that you could see, yeah, as examples for streaming stuff and loading stuff within EclipseStore. Yeah, that's the reason why most of you, I'm pretty sure, are used to use the Streams API, but some of you might not, and that's the reason why we have to talk about this. Any questions so far? Regarding the streams. Okay, so that brings me to the last two topics for today, and then we are good for the fundamentals training. Lazy loading, a little bit more in detail. I also prepared a presentation, and as I already mentioned, so there is a further topic within the advanced storage, within the advanced training, but to cover the main things regarding lazy loading, we just go through this presentation a little bit. Okay, we have to clarify why do we need to have lazy data? Why should we store and load things lazily, and how to use them, the lazy reference, and some best practices that's important to know. Okay, why lazy reference are important? As we already know, EclipseStore is an in-memory database framework, and that is the reason why it's so fast and performant. That means for best performance, data must be in the RAM. So that's quite clear. But sometimes that's not possible because let's say we have 1 terabytes or more than 1 terabytes of data, and we're not able to have that in RAM. By the way, do you know what the biggest EC2 instance is for nowadays on AWS, for example? You could do some guesses if you want. What is the biggest one, the biggest you can order from AWS? That's really interesting. So So I see that 2 days ago it's 484 cores and 12 terabytes of RAM. That is insane. What you could order nowadays. Okay, but yeah, for some application, it's helpful to have all the data within the RAM. But for now, we try to keep things smaller. And in my opinion, it's unnecessary to hold all the data inside the RAM. It's the same on scaling things. We always talk about scaling data and find ways to horizontal scaling data. And scaling is, especially when we talk about stateful scaling horizontally, then we're talking about this is an insane complex thing, and it's insane expensive, I would say. And the point is, with some smaller, I would say, I would not call it a trick, but with some helpful methods, we could prevent the data from scaling all the time, especially when we talk about archive data. So there are a lot of customers that I ask, okay, how much data do you have? And they told me something like, okay, we have 4 terabytes of data. And the next question is, how much binary data is within your database? Do you really need the binary data within your database instead of putting it to an AWS S3 bucket, for example? And the next question is, what about archiving data? Do you really need the whole data all the time within your focus, I mean? So, and then they said, oh, yeah, mostly it makes sense to have the last 3 years. Then I said, okay, that's great. Let's keep the last 3 years within the RAM, but all the other stuff could go. That means on every night you run a job that archives the data to a different database or to a different data storage, and that prevents your data from scaling all the time. Just doing stuff like this prevents your data from scaling, and that's the point. It's unnecessary to hold all the data within an in-memory database. Okay, but let's move on. Why lazy references are important? Because, as I already explained, on startup, all the data will be loaded to the RAM. So that means when we have 100 million objects on the hard disk, on startup, you will have 100 million objects within the RAM. That's it. So when we use some lazy points, that means those lazy spots stays on the hard disk as long as it is needed. And that means only the lazy spots itself. That means when we load 1, for example, when we call get at this collection, for example, then only 6 and 7 is loaded. 4 stays on the hard disk because it's a second lazy step, and you have to load it again. And this is how the lazy reference or the lazy wrapper object is basically working. Okay, when to use lazy loading? I would say always on binary data. So on blobs, on documents, on images, whatever. And a much better solution would be, don't store this to your database. Put it to an AWS S3, but not in the database anyway. Always on huge collection. So now you would say, what is a huge collection? So yeah, for example, some logs or archive data or stuff like that, with less frequented data. Because when you want to search within those collections, you have to load the whole collection at once. That means that could be okay in a way, but you have to find a way to handle those data in a lazy way. So that's important. You should use it sometimes on huge amount of sub-entities. So let's say you have huge objects, and only a few fields of that objects are really interesting for listings and stuff like that. And then you could split up your object in 2 different parts. You have the main data, which is used all the time. So as I said, in listings and so on. And you have a second part, let's call it customer detail, for example, and that could be a lazy part of that, could be a great solution. And use it whenever you want, if performance isn't that important. And in this part of data model or amount of RAM is limited. The point is, and there is an interesting point, you always have to consider the more concurrent user you have on your application, the more data will be will be in your RAM anyway, because different users are loading different data all the time. And that means when you knew that most of the data will be part of the RAM anyway, then it makes no sense to use lazy loading at the end, because the data is loaded and it stays in the RAM. There are some functionality that enables you to release the data at the end. Yeah, but let's talk about that later. It, especially for binary data, it could look like this. So let's say lazy byte, for example. Let's say there is only one image, maybe the cover of a book. Then it makes sense to have it like this. Or if you want to have multiple things, multiple documents, it makes sense to create a string as an identifier, and then you could say lazy bytes. And that means the byte stays on the hard disk. So when you want to load it, you have to use the get method. This is the lazy object at the end, and when you call get, it will be loaded from the hard disk. Yeah, we already talked about this. Using hash map instead of list and set gives you a possibility to search, creating your own index at the end. So this is how to initialize a lazy reference like this. So let's say we have a lazy list of books. And this is an okay situation, I would say. It's not best practice, but for some smaller, less frequented collections, this could make sense, because as I already explained, when we want to stream through a list, we have to load the whole list at once. So that means most of the time you will have the data in memory anyway. That's why I recommend for most low, medium-sized collection, yeah, as I explained. Using hash maps, we already talked about this. That could be a great solution. Maybe the first 4 or 5 digits of the ISBN, that could help you to load all the data, or a specific index, whatever. We already talked about that. And there are 2 strategies to release loaded data, which comes with EclipseStore. The first one is you are able to call a method which is named clear on the lazy image. So now you see that there is lazy image.get. That means with that method, the data is loaded from the hard disk. And with the clear method, you will release that image. But you always have to consider that the image is still available till the garbage collection is running. So the garbage collection, it's not the best to call it manually like I do here, but it's just for an example to give an idea. Okay, the image stays as long as the garbage collection is running. And there is another possibility to use. You could do the clearance by yourself, or you could use the lazy checker. That means this is a functionality which is built in by default. Each lazy reference which is loaded stays in the memory for 30 minutes. After 30 minutes untouched, the object will be released automatically. So this is a built-in functionality, and it will also removed when we reach the limit of 75% of memory. So this is the default. Yeah, you will be able to adjust this on the, but this is part of the advanced training at the end. Okay, we talked about this. Okay, so this is the theoretical part of lazy loading. So as I said, there are much more information and within the advanced training. We're doing some research to see, okay, how much data on the hard disk creates how much data in memory. That's also quite interesting to see. I hope that answers the question, is there a possibility to unload already loaded lazy data? I think I answered this already. Okay, let's have a look to the first presentation. We start client UI. Okay, that's it's enough time to do that at the end. The reason why we added a client UI to see the data, and I just give you an idea how this basically works. You find this directly within the documentation here, REST interface. Here you see that there is the client UI, and I prepared this for you. That means there is a project which I created. It is then client UI. Let me share this to you. Here we are. Nothing special inside that project. There is only a few lines of code. So let's jump into it. Here we are, and on the DB class, you see these 2 lines of code that creates the storage REST service. And this is just for development purpose. You have to remove this in production because there is no security stuff in it. It's really just for development. And the biggest issue at the beginning, or when you start to using EclipseStore, is you are not able to see the data like you are used to when you open an admin front-end of a specific database. And sometimes this could be, yeah, especially at the beginning, that is a little bit weird, I would say. But after a few times working with EclipseStore, you know where your data is, and mostly you create some REST endpoints to see the data, or you create your own UIs to see the data or what's going on. But instead of doing that, we created that client UI. So that means just add these 2 lines of code, and then you have to download just a second, where we are. Yeah, just download this client application and just start it with that command. So let me just doing this for you. Here we are. So this is the download, and I'm using this within. So I open the PowerShell to start that application. Okay, copy paste to start the client UI. And this UI should look like this. So your application, you have to start your application. So let's start this. That's important. So otherwise we could not connect, of course. So application, run as Java application. Okay, up and running. Just double check if there are some data in it. So it should be books, I guess, localhost books. Yeah, you see books are available. And when we now, that's the wrong one. So here we are. And now we are able to connect to that application. And now this enables you to see the data in a different way that you are used to, but you see that in the really a graph representation view. You see there is one root object with the books. It's an array list. You see the type ID, and that enables you to see the books in it with the object ID and the type itself. You see the data in it. It's a little bit different to the normal view of a database, but that could help you to see what happened inside the database and to help you to develop stuff. To be honest, I personally never used that UI because I always created my own REST interfaces or UIs to see the data at the end. But maybe that could help you to get access to the data, especially at the beginning. Okay. Question. I've been wondering how securely the data is stored, especially when it comes to string storage in memory. Good question. You will not be able to read. The data isn't stored in a readable format. It's stored in a binary format, and you will not be able to read the data. We could give it a try. So let's jump into a channel file like this. And this is the data. So of course we should use a hex editor to see that, but now you see the data is not stored in a readable format. So that's point number one. On the other side, there is no embedded encryption available within EclipseStore, but there are possibilities to create encrypted persistent volumes, for example, or an encrypted AWS S3 bucket if it's really needed. But this will decrease the performance, especially when you have a lot of lazy stuff ongoing, because the data within your RAM, it's in the RAM anyway. But when you need to lazily load data, you have to encrypt it and so on. Yeah, it's up to you. But the data itself, it's not stored in a readable format. And if some intruders are able to access your binaries, it's too late anyway, I would say. Does that help a little bit? Okay. Also a good point. What about backupping and stuff like that? There are two embedded mechanisms to create backups. This is part of the advanced training. But we could jump in shortly to documentation. No, that's not the right one. What a mess is ongoing on my computer. So, okay, so backup. There are two backup mechanisms. I said, where is it? Storing data. I need to find it. Is it within loading? Storing, I guess. No, storing. Not able to find it. Configuration. Here we are. Yeah, backup. Yeah. So, as I said, two different backup functionalities. One is the continuous backup, and I always call it a mirror. That means when we add a property that is, it looks like this within the configuration, that means a second mirror will be written on each store call. That means there is a second storage that grows the same than the normal storage. And it's also possible to write down the primary storage to a persisted volume, for example. And on top of that, you could write the mirror directly to an S3 bucket. So that is what mostly happens on our customers. That means you have always a backup within your S3 bucket. And there is another possibility to there's a full backup. And that's important to provide that kind of functionality, because I strongly recommend not to use some Kubernetes embedded stuff, for example, cloning a persistent volume, for example, because you never know when MicroStream is going to store something. When you remove or when you're cloning the storage and EclipseStore is storing data at the same time, then you will, the damage is the storage will be damaged at the end, because there is only half a write cloned by Kubernetes, and that's the reason why you should never use those cloning methods within EclipseStore. But there is a possibility. I knew that Spring, for example, has some embedded functionality to recognize when a clone is made by Kubernetes, and then you could ensure not storing for a short moment. Maybe that helps a little bit. But yeah, instead of cloning stuff, using the full backup mechanism, and it creates a full backup of your whole storage and writes it somewhere, I think that's enough. And in case of something went wrong or something crashes, just copy the backup back to the persisted volume and everything is fine. Yeah, that's it. It's quite easy. You have to take care by yourself how many backups created, and to ensure that the oldest backups will be deleted after a short period of time, whatever. But this is business logic at the end. Okay, I hope that answered it a little bit. How can I start a second instance of Micronaut? Use the Micronaut YAML file to set a specific port. You will find that in the Micronaut documentation. Okay, just a short, just short details about backupping stuff. Okay, so that brings me to the end, and let's go through that. We talked about EclipseStore in general. We talked about a quick step-by-step configuration. We did this on that hands-on. We talked about CRUD operations, creating a data model, queries and streams, lazy loading a little bit, and at the end, the client UI. I think that's all for the fundamentals that enables you to start with, to creating your first storages and so on. It's enough time for your questions now, but so based on the topic, that's all from my side. There are no more stuff I have to tell you for now. It's your time. Answer or ask questions. We have another 20 minutes. So that's how does your company make money? That's a good question. So as you know, as I told you, we have a lot of customer projects. They, especially the Allianz, for example, they moved from PostgreSQL and MongoDB to EclipseStore. There are a lot of customer projects we do. Then, of course, if you want to use EclipseStore within production, it makes sense to have a support contract. There are some customer that they crashes their storage and they need to recover the storage. That's why support is important. And on top of that, we provide enterprise services and also our cluster solution. So that means we provide cluster infrastructure. That means you are able, or you will be able to create a Micronaut project like this, and that works for you quite fine for let's say a year. And after a year, you decided, okay, I need a horizontal scaling of that Micronaut service that provides the data at the end, and then you could provide these applications to our cluster, and we doing the cluster replication at the end. We replicate the data and so on. And yeah, that costs money, and this is how we make money at the moment. Can you repeat how to sign the advanced course? Yes, but I guess Marcus said something he wants to share a code that enables you to get it for free. So yeah, I take it with me, and you will get an email after that, and that email contains the code at the end that enables you to book the advanced training at the end. So let me take a note. I will not forget this. Okay, got it. So again, for getting a certificate of the fundamentals training, just register on our cloud front end. I hope it is up and running for now. Let me just double check this. It was down for maintenance for a short moment. So let me just double check. Yes, here we are. So here you see this is the cloud front end. And when you click on certification here, you will be able to get your certificate of the course. And you could download it and yeah, print out whatever you will get. You will get it here. But remember, you have to register with the same email address like here on the training. That's important. Otherwise, let me know. Just send me an email. I just have to share my email address also. It's c.net. Okay, so if you have any question, feel free to send me a mail and I will do my best to answer it. Some more questions. In case if the data provider crashes, does the thread dump of the attribute the data? Also a good question. This is also a part on the advanced 2 training, especially it's a topic, so I call it error handling. The point is, I always said, okay, what could go wrong? So when we think about a normal database, there is a lot of things that could go wrong. Network connection is not available, server is not available, whatever. So a lot of stuff could go wrong. On EclipseStore, we are quite close to the storage at the end, and that is not that big there is not that big problem, I would say. The point is you should have a proper error handling with try catch, and I always recommend if something goes wrong, just tear down the application and yeah, fix it or doing stuff. The storage in the end, if something is written in half, for example, let's say you write something and Kubernetes disconnected the persisted volumes, for example. Then there is a built-in mechanism that repairs the storage, that cuts the last half written data, and the data is fine at the end. So that is not really a big problem. But the last call is gone in this case. Yeah, but this is all covered by the advanced 2 training, error handling, and best practices stuff working with EclipseStore. How to encrypt data? There is no embed functionality of encrypting something, but I would recommend using an encrypted storage target. So that means encrypted AWS S3 bucket, for example, or I don't know if there is some encryption available based on the persisted volume. I've never used that before. Yeah, that makes sense to use it like this. Okay. Okay, so we have enough time you could ask more questions, no problem. So, but for now, let me say thank you for attending the fundamentals training. It was a great pleasure for me to have you. As I said, if there are any questions, feel free to send me a mail. I will answer it. Yeah, that's it for now. I wish you a good evening and good night, and see you on the advanced training. So, see you and bye-bye.
Hi, native language is German. We can do this in
Okay,
German.
dann können wir es auf Deutsch klären. Ich versuche es gerade ein bisschen zu verstehen. Da geht es wahrscheinlich um Native Images, oder?
Ja, genau.
Native Images sind tatsächlich noch ein bisschen, ich will nicht sagen ein Problem, aber ich bin mir noch nicht ganz so sicher, inwieweit die vollständig unterstützt werden. Ich weiß, wir haben da schon mal was in diese Richtung gemacht, aber gute Frage. Müsste ich tatsächlich noch mal ein bisschen tiefer da reingucken. Kann ich jetzt so nicht beantworten. Nutzt ihr die oder benutzt ihr die tatsächlich?
Nee, noch nicht. Es ist auch ein Plan für die Zukunft. Einfach wegen der Speicherersparnis oder der versprochenen Speicherersparnis und der schnelleren
Startup-Time.
Cold
Ja.
Starts. Ne? Ja, klar.
Ja.
Das ist schon
Also,
interessant für uns.
das ist aktuell tatsächlich ein interessantes Thema. Ich bin mir gar nicht so sicher, ob es jetzt im Zusammenhang mit einer Storage so viel Sinn macht, weil was man nicht vergessen darf, ist ja, dass on Startup auf jeden Fall die Daten geladen werden müssen. Das heißt, obwohl man dann eine große oder eine Ersparnis durch das Native Image hat, glaube ich, macht einem das Laden der Daten genau diese Ersparnis wieder zunichte. Also deswegen bin ich mir gar nicht so sicher, ob es so Sinn macht, stateful Services mit Native Images zu bauen. Also ich kenne Native Images nur im Zusammenhang, wenn wir stateless Sachen haben, wie zum Beispiel, keine Ahnung, ein Report erstellen oder sowas. Da ist es total cool, weil es halt schnell startet und wirklich, wirklich schnell ist. Aber mit stateful Sachen wäre ich da ein bisschen vorsichtig. Ich weiß auch ehrlich gesagt gar nicht, wie groß die Verbreitung von Native Image derzeit ist. Da gibt es ganz viele, die sagen, naja, das ist irgendwie schon, hört sich gut an, aber damit umzugehen ist eine ziemliche Hölle aktuell. Ja, also
Ja.
ich weiß nicht, ob das also speziell mit so In-Memory-Storages und so weiter, wir haben da schon mal drüber nachgedacht, aber ich glaube, das war nicht so erfolgreich, ehrlich gesagt. Ja, also wir haben im Rahmen von unserem Cluster haben wir uns mal damit beschäftigt, aber wir sind dann zu dem Ergebnis gekommen, wenn der Cluster merkt und wenn Kubernetes merkt, dass zu viel Last auf den Load Balancer kommt, dann fängt er also wenn wenn jetzt zum Beispiel 2 Pods zu 60% oder zu 70% ausgelastet ist, dann fängt er an, eine zweite Node hochzufahren. Und bis die anderen beiden dann nicht mehr können, ist der ohnehin schon hochgefahren, egal ob Native Image oder nicht. Von daher ist es oftmals vielleicht nicht notwendig, das zu haben. Aber ich glaube, das ist cool für stateless Sachen, aber für stateful Sachen bin ich mir nicht so sicher. Einfach mal ausprobieren, wie gut es performt. Wenn es Probleme gibt, uns Bescheid sagen. Ich würde es einfach mal testen. Es gibt so viel cooles Zeug mittlerweile, was man da machen kann. Ich habe zum Beispiel mal versucht, eine Datenbank auf AWS Lambda zu machen mit EclipseStore. Also tatsächlich die Datenbank so klein zu hacken, dass die auf Lambdas funktioniert. Das hat tatsächlich ganz cool funktioniert. Vor allem, wenn man, ich habe so ganz kleine so Endpunkte eingebaut, die sozusagen diese Lambda am Leben halten, sodass die nicht komplett in diesen Cold State zurückgeht, sondern so in diesem Hot State verbleibt. Kriegt man eine Datenbank, die ziemlich effizient und schnell ist, für ganz wenig Geld eigentlich. Ja. Da gibt schon viele coole Sachen, aber ja, muss man halt immer auch den Use Case dafür haben.
Ja, was meinst du jetzt mit wenig Geld? Wenn die Lambdas doch am Laufen bleiben, dann zahlt man ja trotzdem, oder?
Ja, aber dieser Hot State kostet nichts. Bei Lambdas ist es ja so, es gibt ja den totalen Code, dann ist quasi gar nichts da. Dann dauert es relativ lange, ich würde sogar sagen 1, 2, 3 Sekunden, bis die da ist, je nachdem, was da drauf deployed ist. Aber man kann die dann in so einem Hot-State halten, indem man die relativ regelmäßig mit so ganz Mini-Requests sozusagen triggert. Dann verfällt die nicht in diesen totalen Cold-State, bleibt im Hot-State, kostet aber nichts an der Stelle. Und
Das wusste ich, das ist ja cool.
das ist ziemlich cool. Da kann man, so, das ist sogar AWS gibt es als Tipp raus. Die haben auch so eine eingebaute Funktionalität, die kostet aber dann was, dass man sagt, okay, 3 oder 4 Lambdas bleiben immer im Hot State. Das muss man wirklich teuer bezahlen, aber das kriegt man relativ günstig, indem man die einfach so in regelmäßigen Abständen einfach triggert. Dann bleiben die da in diesem State. Ja.
Okay,
Für
ja, vielen
Firmen
Dank.
wahrscheinlich relativ uninteressant, aber zum Basteln schon ziemlich cool.
Mhm. Ja, genau. Danke für den Tipp.
Genau. Ja, einfach mal ausprobieren. Also wir machen im Moment vielleicht so jetzt mit EclipseStore. War selber jahrelang, habe ich mit Hibernate und normalen Datenbanken gearbeitet. Ich bin froh, wenn ich es nicht mehr anfassen muss. Ich mache mittlerweile ausschließlich nur noch EclipseStore-Projekte. Ja, wir sind super glücklich damit, auch in den Kundenprojekten. Das macht echt super viel Spaß. Ist ein bisschen eine Umstellung, aber ja, wie gesagt, einfach mal ein bisschen rumprobieren. Dann
Ja, das Tooling, gell, und die Art, wie man damit umgeht, Schema-Migration, das ist halt alles anders, ne? Muss ich echt mal dran gewöhnen.
das stimmt, ja, ist
Stell ich mir
tatsächlich.
vor.
Das ist komplett neuer Ansatz, wie man denkt. Aber wenn man so ein bisschen nachdenkt und drüber sinnet, dann gibt es halt ganz viele Situationen, wo man sagt, das macht eigentlich total Sinn, das genauso zu machen. Warum sollte man Daten ewig weit durch die Gegend schicken zu irgendeinem Datenbankserver, nur damit der das Zeug auf irgendeiner Platte ablegt? Ja, da gibt es halt viele Sachen, die da halt ganz viel Sinn machen. Und ja, das ist halt das.
Wie schnell ist jetzt die Transformation? Habt ihr da auch Erfahrung? Also mit großen Daten, wie schnell können die da in das Binärformat konvertiert werden?
Das ist schon super schnell. Also ich glaube, es gibt aktuell keine schnellere Serialisierung wie die, würde ich jetzt mal sagen.
Okay.
Also nein, das will ich nicht sagen. Also es gibt schon Sachen, die schneller sind. Das Problem ist bei uns immer, die Serialisierung, die wir haben, wäre grundsätzlich deutlich schneller wie andere. Aber in Verbindung mit der Storage ist es so, dass wir noch so Storage Dictionary Sachen schreiben müssen, damit wir quasi wissen, welches Objekt gehört wohin und wo sind die Referenzen. Und das ist der Grund, warum die Serialisierung vielleicht ein bisschen langsamer ist, wie jetzt zum Beispiel eine JSON-Serialisierung oder so. Also es hängt halt auch immer so ein bisschen damit zusammen, wie groß sind die Objekte, die da serialisiert werden. Also da gibt es viele, ich sag mal, Bestandteile, die da Einfluss nehmen. Das kann man so generell nicht sagen. Wir sind ja auch, sage ich jetzt mal, keine reine Serialisierung, sondern wir sind ja wirklich eine Datenbank. Und ich glaube aber, die Zugriffszeiten, also ich kann vielleicht mal, das ist ganz interessant, ich habe es gar nicht gezeigt, aber das wäre vielleicht nochmal, ist eine interessante Sache. Ich habe eigentlich so.
Eine Frage jetzt noch, die Deserialisierung, die ist aber dann schnell. Habe ich das richtig verstanden?
Ja.
Ja,
Also,
okay.
Moment, ich versuche bloß gerade das zu finden. Hätte ich eigentlich noch gerne gezeigt, aber hatte ich nicht mehr so viel Zeit. Typ Performance Demo App. Genau. Sofort. Das war nicht. Was ist denn das Demo? Genau. Das ist ganz interessant, weil man sieht hier mal einen Vergleich zwischen PostgreSQL und dem, wie schnell EclipseStore ist. Wir haben hier auch gebaut einen Versuchsaufbau auf 2 EC2-Instanzen. Die haben beide dieselbe Größe. Und auf der einen EC2 ist quasi die PostgreSQL nativ installiert und die schreibt auch auf dieselbe Instanz. Und die kommuniziert mit einer REST-Applikation, mit einer Micronaut-Applikation, die dann sozusagen die Daten weiterleitet. Und auf der anderen Seite haben wir Micronaut mit EclipseStore. Und Da kann man mal schön vergleichen, wie die Performance ist zwischen den beiden Systemen. Und zwar geht es hier wir haben hier einen REST-Call, der liefert 1500 Bücher zurück mit Title, Value, Autor und ISBN und so weiter. Und das ist wirklich nur ein ganz normaler Select. Und da sieht man mal, was so die Unterschiede sind. Also nicht nur, dass wir mit MicroStream also bei 3,6 Millisekunden sind für diese Bücher, was hier zurückgeliefert werden. Wenn man sich mal die CPU-Auslastung dieser beiden Systeme anschaut, das ist Wahnsinn eigentlich. Also wir sind hier limitiert auf 1200. Aber ich möchte wissen, wie viel mehr wir zurückliefern könnten, also Read-Requests sozusagen, wenn wir das voll ausschöpfen könnten im Vergleich zu dieser PostgreSQL. Das ist schon Wahnsinn eigentlich. Da gibt es viel mehr solche Vergleiche. Und interessanterweise haben wir obwohl wir in Memory sind, haben wir dann dieselbe Performance. Das Interessante dabei ist, dass viele dann immer sagen, das ist ja eigentlich ein unfairer Vergleich, weil ja MicroStream ist in Memory, muss natürlich logischerweise viel schneller sein, weil ja Postgre das quasi ja auch. Was aber nicht stimmt, weil die REST-Applikation ist mit Hibernate geschrieben und da ist das Caching an. Das heißt also, der cached eigentlich auch die Objekte in Memory, sollte also fast genauso schnell sein, aber diese CPU-Auslastung hier fällt alles zurück auf diese Deserialisierung und Serialisierung der Objekte. Und also selbst aus dem Cache, ja. Also das ist echt krass, wie viel Performance da verloren geht mit der Datenumwandlung. Das ist echt unglaublich.
Sehr interessant, ja, das muss ich ausprobieren mal. Wirklich. Ja.
Ja.
Okay.
Einfach mal testen und dann
Mhm.
vielleicht sehen wir uns ja in der Advanced-Schulung dann.
Ja, genau, alles klar. Danke.
Gut.
Dann schönen Abend noch.
Schöne Woche noch. Ciao.
Ja, ciao.